Hey folks, welcome back. I hope that you've had a very productive morning so far. The first speakers were great. I really enjoyed the presentation, so I'm hoping that you're getting something out of the conference as well. This panel, sort of intended to look at cross-industry lessons, really embodies much of what this conference is about. So the whole idea to share ideas, learn from each other, learn things that are perhaps a little orthogonal from what you might ordinarily be doing. So I'm excited about it. Hopefully it will also give you ideas for moving forward. We're very fortunate. We have a very knowledgeable panel and they're also from different industry segments. So I think that the opportunity to learn diverse ideas should be good. I'm going to briefly introduce the panelists, and then when we start, I'll ask each panelist to, again, briefly say what their personal background is, what they do in the company, and what the company is, just very briefly. And then I'm going to ask 5 questions of them. And it's a starting point. This is definitely meant to be more interactive, so I'm sure people are going to jump in. But the questions I've asked them to think about, relatively general, are the following, and I guess there are 6. How do you know when HPC is needed, and how did your company know, and who got the ball rolling? What were the biggest challenges from your particularly industry company perspective in adopting HPC, and how were they best handled? What's been the impact on needed IT support, training, and budget? What were the big gains, ROI, and how have you measured those gains? Can you describe the HPC systems your company uses? And finally, what advice would you offer to companies considering moving up? There's a lot there. I don't know if we'll get through all of them, but it kind of covers the ground of what are you using? Why did you start doing it in the first place? What did you learn? So let me introduce you to the panelists. As I said, we're very fortunate. We have several industry segments. From the auto industry, we have Dr. Jamel, I hope I'm pronouncing this right, Uddin, who is a senior HPC administrator for Dana Holding Corp. From the life sciences world, we have Dr. Ari Berman, who's the GM and principal investigator at Bioteam. Bioteam is in the life sciences area. I've mentioned them before. I know Ari has spoken here before. From the aeronautics world, we have Larry Patterson, Senior Manager, HPC, Gulfstream Aerospace. And from the marine engine world, we have Arden Anderson, Manager, Design Analysis Group from Mercury Marine. Really, all the right titles. These are people who should know how to go about this. So let me start, as they chuckle. So let me start with asking each of them, and I'll just walk down the line here to say a little bit about who they are, what their responsibilities in their companies are, and briefly what the company does. Ari, maybe you could start.
This thing on? Yes. All right, hi. My name's Ari Berman. As he said, I'm the general manager. I run the government services portion of Bioteam. We are essentially a very small high-performance consulting company. There's 14 of us, but we span the entire gamut of life sciences in general, in terms of enabling science in computer-aided research. My personal background, I have a PhD in molecular biology. I'm trained as a neuroscientist, and I did 12 years of laboratory work and bioinformatics work in 2 successive postdocs. And then simultaneously, I'm one of those oddballs who also has 17 years of experience designing, managing, and using HPC resources at various scales, from single laboratory up to institutional huge sizes. So that's my brief background.
Okay, Larry, you just move ahead.
Larry Patterson, as he said, I'm the Senior Manager of High Performance Computing at Gulfstream Aerospace. We are a General Dynamics company. My background, the reason I got into HPC, of course, is because I was a nuclear engineer and it just made sense. I got out of the Navy after about a decade in Nuke Navy, and then finished my electrical engineering degree, and I went to Gulfstream about 18, 19 years ago as electrical engineer. Came up through the engineering group into project engineering, and somehow I jumped on some IT projects, and as the world turned, became an IT guy. So With all of my science background, about 12 years ago, started putting together what we now call high-performance computing at Gulfstream, and we've stood up the team, and I've had the pleasure of running that since I've been there. Gulfstream, if you don't know, is that aircraft business jet guy that we do these kind of cool jets.
Are you handing out samples?
Yes. I'm getting mine soon because I let them take a little bit out of weekly, so my great-great-great-great-great-grandkids.
So this is like the Oprah show, everyone gets a Gulfstream?
Oh, absolutely. Just see me on Friday. I leave Thursday.
Hello, my name is Jamel Uddin. I am a senior HPC administrator at Dana Corporation, and Dana is one of the oldest corporation related to the automobile industry, and we provide axle and driveline related product. And my personal background is I have a PhD in computational chemistry. I started around 1997. So from there, I have been working in different universities and national lab to corporation as a HPC-related scenarios. So I also do some research. I have background in computational chemistry, material science, and also surface science-related areas. But currently, I also became an IT guy, as Larry has mentioned, to give the service to our HPC community and try to solve their problem or also increase our HPC capabilities. Thank you.
Hello, I'm Arden Anderson. I work for Mercury Marine. I guess my background is in computational mechanics, structural mechanics, and explicit dynamics are the main areas of study. I started my career at Lawrence Livermore National Lab. Got a lot of exposure to supercomputers out there. I think amongst the smaller systems that I ran on there still are probably along the size of the couple of hundred cores that we currently have at Mercury Marine, but I do think that's one of the things I've helped bring to Mercury Marine in the decade that I've been there is help them go from desktop computing and kind of lightweight analysis sort of to just verify some assumptions to we do fairly realistic engineering simulations now. Our commercial solvers include ANSYS, Abacus, STAR, and others. So we're very much a user of HPC for performance computing. We work with our design team as sort of a test facility of sorts. That's been a big thing that's helped us out is really looking at the computer simulations as a form of test. So that's my job at Mercury Marine is really to manage the workload for the tests and make sure that we've got the proper equipment to get those tests done in a speed or cadence that matches our product development cycles. So.
Okay, so let's start with how do you know when you need it? I mean, what's the path? What happens to sort of turn the light bulb on that that you need to use some sort of advanced scale-out computing versus what you were using? And maybe we'll start with the newest member. Arden is graciously filling in. We appreciate that. Arden, maybe you could tell us a little bit. What is it that prompted it? What was the process,
Sure.
and who drove it?
Yeah, I think what really told us we needed it was number one, an awareness of the community. I think several of our analysts kind of knew as I came in to Mercury Marine in 2005, I had exposure to what could be done with simulations when there's enough computing power to support getting the results fast enough. So the environment I came into in Mercury Marine in 2005 was such that they had relatively accurate simulations they could do, but too slow, or they could do not enough accuracy or realism in a way that was kind of fast enough. So we saw that gap, right? Opportunity is the difference between what you can do right now or between what's possible and what you're currently doing. So we identified the opportunity. We got buy-in from our management where they said, this stuff looks great, but it's too late. We did a lot of method development and technology demonstrations. And, everyone said it looked good, but how long does this take? And weeks and months wasn't a good answer. So we went about fixing that. And through cooperation with our vendors and things like that, we quickly identified a path to getting things done faster and, pretty quickly got HPC involved into our organization.
Okay. Larry, maybe?
Well, Gulfstream, of course, we need somebody to design the new aircrafts. So probably 30 years ago, back in the 80s, you had some senior aero kind of guys, the staff scientist guys. They were trying to reach for the biggest computers they can. So back in those days, we were probably the HP series. In the 90s, we went into paying money to some supercomputing center, and they'd pay. I asked them one day, why did you pay $100 grand for so-and-so? And they said, well, that's how much we had. So basically, they designed the amount of points they could design. They ran out of money, and that was their supercomputing. Then we went into some convex systems, and then in 2000, we went through the V-class and the N-class HPs. Get on up into later in 2000, we adopted, of course, the architecture. But early on, to start it, it was the scientists. So that's why I wanted to jump into HPC a decade or so ago, because it comes around the science. And I was a little different thinking than our particular traditional group of IT, where it's mostly about the science, and then you find the hardware that runs that science or that particular science the best, and you fine tune it, and you bring in the people to do so.
Ari?
I have a somewhat different perspective on this. Bioteam as a company, we are virtual. We don't have an office anywhere in the world except our own houses. So we have no infrastructure anywhere, although that's about to change, Dan. Where we sit really is that as a consulting company, we're in and out of about 45 organizations every year. Everything from, as I said, single laboratories to entire government agencies to most of the pharma companies in the world. And as we go into these places, what we find is exactly what Larry just said, is that the science drives HPC need in almost all cases for our application, okay? Whether that be research and development for drugs, whether that be people who are trying to figure out how to cure cancer through next generation sequencing, whether it be people who are modeling small molecules and how they adapt to proteins for finding new and more specific drugs to solve disease. All these applications are very, very intensive computing applications and very, very difficult IT problems to solve. All right, we're talking, the talks earlier, we're talking about massive amounts of data movement. We're talking about every type of file and size of file you can imagine. And you're also talking about every kind of algorithm, from really well-defined parallel algorithms to things that just completely suck, that have never, ever been vetted by any computational engineer ever. And you have to be able to support all these things in an environment. HPC tends to strike that balance of being the type of system that can manage capacity supercomputing and capability supercomputing needs in one system, right? And that's actually harder to do maybe than it sounds, because the capability stuff tends to be expensive and the commodity capacity batch stuff tends to be a little bit less expensive. But if you do it right, you can sort of blend it all and work it out. And PayPal's doing some of that stuff, and I'm sure a lot of other people are here too. So in essence, because we don't have a particular business need for HPC, my answer is the field, the way I see it, is about 25. So I've in the last 2.5 years, I've interviewed about 800 scientists regarding their HPC needs. And the way I see it is about 25% of all laboratory scientists are going to need HPC in some form in the next year, all right? And that's because these laboratory technologies are really generating enormous amounts of data all of a sudden. And these technologies are improving at a cubic rate, way beyond what data center refreshes are. And so I would say 25% of our field as an answer is really what needs it. And if you're not doing these techniques that require this data analysis, you're probably behind. So if you're in a bio-IT organization, you probably need HPC.
And Dr. Uddin?
Thank you. So I give a little bit different view of the industry that I experience. So I was first actually hired at a company in Silicon Valley as a startup. So they thought that they can start up something like a lithium-ion battery technology company. So I had some background in the material science simulation, computational area. So they wanted to set up a computational lab as well. that's just elementary idea that how we can actually utilize the HPC system. So one day I got a call. I was in Rice University in Houston, Texas, said that would you like to join, and you can take the lead for setting up the HPC system there and help us to grow there. So I actually took that opportunity, and I was given like $150K budget and asked me to set up the way you can. So I took the opportunity and tried to get some like quotation and interconnect technology and the good server which will be suited for me with a small amount of budget. And so I actually started doing that and then set up the computational system there. Once it is done, like we have a server, we have the computational system, we have the queuing system, everything there. And then after it is stabilized a little bit, then I started doing some simulation as well because I had that background. Yeah. So in the small companies or startup, people need some people sometimes that can actually wear multiple hats. So you can do this, you know technology, what the problem is, you can go quickly there and set it up. So in other cases, I can say that in almost all cases, I have been to 4 different companies. A couple of them, like one I mentioned about that was a very startup, but other like 100-year-old companies. And one example I can give, like I was working as a company in the UI called Waynes, Illinois. They make the glass product, the oldest company, and I think they make half of the glass product in the US or in the world. So they wanted to reinvent the glass. And how do you get better glasses? Glass is there for like thousands of years or 8,000 years it was there. People are using silica and then soda ash and melting it to get glass. But we need to get smart glass nowadays. Now you know that you have iPhone, you have Godzilla glasses. So those are actually recent inventions. So to do that invention, you have to do some research on that. And material science can help there. So at Y, actually, one of the global VP of R&D, she was at Dow Chemical, so she had background in HPC because Chemical Corporation actually using HPC for a long, long time. And that is what my background is as in academia. So when they started, they couldn't figure out that what type of system they are going to use. They somehow, they talked to the IT people, they say, okay, we can set it up. And they set up one cluster with the Windows system. So the goal was to do engineering simulation and also do some like R&D type of research. Now, if you look at the program or parallel program which can run on the HPC system and can do research, there are very few options for the Windows system. So that was one of the mismatch for HPC to be in the area. So when I was there, I work with the IT VP and also the VP of R&D, and they gave me the chance to take the lead. Then I quickly communicated with the engineering community and also tried to write some memo type of letter that why we should actually move to Linux type of system where there are all the program in the computer like chemistry, physics, or glass science. You can simulate it. And also you have the engineering simulation program like CFD or CAE, and you can use it. And I talked to the people who are supplying the like licenses, that can I actually take up the Windows version and put the Linux version without any cost? They said, sure, you have the license. So this is one of the examples I actually experienced, that how can we utilize our expertise as a scientist and talk to IT and also engineering community, scientific community to get the ball rolling. Thank you.
One of the things that everyone has said is sort of science, has driven things a little bit. You can't do something or you can't do it fast enough, or a Windows system is not capable of handling it at all. I'm still curious before we leave the topic about driving it forward. So you identify a need. How does that come to fruition? Is it typically a single champion, a couple of champions? How do you convince your company to spend on HPC, to actually take the plunge? And maybe Larry could start with that.
It's not a single champion. Back in the older days, when you have the really smartest guys in there making the most money, doing the most science, they are the guys who drive it. But that was in the early days where it was just Arrow. In our world, If you make the sexiest jet, the one with the longest legs, the fastest flying, you want to go after all the superlatives. Well, to do that, you better have the shape right. And it better be good enough for the stress guys. Everybody wants to make a different plane. An aero guy wants to make a wing and have a big flying wing, and now no one can ride in it. There's no engines that can hang on it. The stress and structures guys, they want to tie everything together so it looks like something 40 years ago and it won't even get off the ground. You have to weigh it between all of the disciplines, all the science disciplines, and you run it through. So once you have that perfected, it still comes down to the aero guy. The aero guy sets the OML, the outer mold limit, that contour. And that contour better be the best. It better be the best shape, because when we get the legs that we have spec'd out, we still want to beat all the competition and exceed that. So once the aero guys were behind it, I saw that as the engineer going, let me go to IT. And IT, in the old traditional, and we've heard this throughout the conference so far, in the old traditional ways, Unix, AIX, Windows, no one understood. Of course, I'm not an HPC guy, so I stayed in a Holiday Inn Express. On that night, then I decided, let me go figure out how to spell this thing, HPC. So I really started embedding myself in the technologies and really trying to match it to the science. So now they had their champion who was half engineering brain, half IT brain, and I had to go try to sell that into IT. That is a struggle for our traditional enterprise IT with half outsource, half insource. It's very difficult to get those leading thinkers. So we had to develop that internally. I had to go find the guys who were like-minded. I had to pull that team together. But then early on, years ago, I found you can't drive it out of IT. So I ran the biggest scam in history. I got the senior vice president of engineering to budget everything for me, stick it in his budget, and I burned his budget as if I were an engineering group. I've built it to where it's an outsource. It's a entity unto itself. If I had to go work for Larry Patterson.LLC, we could still run the exact same business, because every feed comes from engineering. The money comes from them because they're telling me exactly what they need. We look at the utilization. We know the use case. We know where the strategy is. We know the multi-year. We know all the secrets that we're going to keep for multi-years to beat our competitors. But then I have to go back and on the IT side, okay, how do we do this? So I have, as you said yesterday, I'm the dumbest guy in the room. I hire all the smart people. They tell me the things that I need, and then I do the sell. I go try to pull it off, and I get the engineering backing. I don't go through CAB change boards of the IT industry. I don't go through, we make our own. Engineering is my change board, but I work for IT. Engineering tells me the budget. IT does all of their budget. Here's my CapEx, here's my OpEx. Oh yeah, and by the way, here's the line item that's HPC. Nobody touches that budget. So we have sold it over the last decade and shown the value and put the G650 in the air to where it crushes the competition. Now I go say, okay, do you want the next best-in-class aircraft, or do you want the next, best-in-craft air? So which is it, next best or next best-in-class? So HPC positions the comma.
But both a stealth and then a long-term effort. I mean, you sort of, as you say, stepped around IT, got the budget approved through a different channel, and then over time proved it. Was integrating with IT, how challenging was that? Did you have two separate systems? How did you interact with them? Completely separate.
I now have my own network. We now have two networks, right? Mike, he's back there laughing because he's like, he felt sorry for me. I went through the gauntlet to try to pull it out. It's hard for the little guys. We're small, one of the smallest teams, one of the biggest CapEx budgets. Small team, so smaller OpEx budget. But my training budgets and all those, and we'll get into some of that, are way up there, and I don't yield. I don't give back. They want to take it down. I fight for every little piece. We pulled it all out. Network, compute, and as of this year, storage. We own it all, end to end. And that was in our company, with traditional IT still being half in and outsourced. It's the only way that we could do it, and now that allows me to be that entity between the two.
You know, Arden, you look like you had a couple of comments on this topic.
I would say some of what you said was also true of our situation at Mercury Marine. Probably not so much the stealth portion, but definitely engineering driven. Had to take ownership of this, and I see the PayPal guys there, and what they said this morning really was pretty true of our experience is once there's something successful, people like to get on board with that. So engineering, I think, drove the bus, showed some successes, and then we opened the door and a bunch of other people got on. IT is much more open to having engineering infrastructure in their server rooms, because it very much is IT's server room. Engineering did not have a place in there prior to our HPC endeavors for engineering simulations. We very much have our spot there now, and we talk about expanding, and they cooperate. 10 years ago, that probably wasn't as much cooperation. So I think those guys are quite wise with just demonstrate capability, demonstrate a return on investment. You were speaking about that, and then things get easier. So as with anything, if there's a good idea, just go do it, and other people will allow for more good ideas later.
One more quick comment. Separate, full-up data center. We don't share data center. They have a couple of them. We have our own. It has turned into, now it's the engineering data center. So we kind of manage it, and then they have a title guy that's the data center manager guy. And we tell them the things that we want. And so when we build new data centers, it will be driven out of us, driven from engineering.
Yeah, that does sound like a different approach in the sense that, keep maintaining that distinction over time can't be easy. Everybody wants to rationalize budgets. How can we make things, a little less expensive? Ari, I'm kind of curious because my thought with you is in the science world and the life science world, which I know a little better, people are probably just hungry to have whatever they can have. So it's less of a selling point. It's just finding a way to actually implement it. Or do I have it wrong there?
Well, okay. Anyone who knows scientists, scientists are ornery, they're stubborn, they want it all right now, they want it for free, and they will hoard everything they can get, okay? And so they're a class unto themselves. I'm one of them, so I understand. Okay, exactly, right. So I know exactly where it comes from, and I have to fight that all the time. But the issue, at least in life sciences that I've seen, HPC, and actually I'm just going to abstract this to research computing at all, is really a cultural institutional barrier problem, okay? In that traditional IT was meant for business enterprise, right? In that IT created solutions, they made all the rules, they created all the policies, they're the ones who procure everything, they're the ones who, and they hand you something that you're supposed to work with. Okay? If you do that for scientists, it does not work because it creates an added barrier of those scientists trying to figure out how to use this for what they need, right? It's designing IT for the sake of IT versus designing solutions for the use case, right? It's a big, big difference. And so in the organizations that I've worked at, NIH is one of our biggest customers, and we're working with them on an agency level, and they're starting to get this. And believe me, the government is probably one of the most hard-headed environments in a research IT that you can possibly imagine. They want to be 20 years behind because they feel like it's safer, right? And it's not, but and so trying to drive these organizations forward into being ahead, which is where they should be and can be, is a really interesting challenge. And so it's about breaking those molds. And to Larry's point, we see a number of different models emerging. We see research computing versus enterprise computing, and they're separate. We've been pushing this whole concept that DOE came up with a while ago called Science DMZs, which is a completely separate, high-performance research network that's outside of the enterprise network, right? So that all the firewalls and policies don't inhibit the flow of research data, right? And we put HPC there, and you put all sorts of stuff there. That's happening because the enterprise doesn't know how to integrate this yet. And still maintain their security and their policies. So I see a mix. Sometimes IT organizations really adopt it, and sometimes they don't.
But it sounds like, as a general case, it's the use cases and those involved with solving that problem driving forward as opposed to IT. And then
not always. It depends on the organization.
Okay.
There are some IT groups that go, hey, we need HPC now, and they throw up an HPC, and they're like, here's scientists, and the scientists either use it or they don't. Oftentimes when IT will build a solution that doesn't match their use case at all, they'll still end up building clusters under their desks and use those instead. And IT's like, what's going on? What the hell? Right? So it depends.
So, quickly, as an advice to the audience, what do you do? Do you look around and say, okay, I have a receptive IT organization, I have an aggressive science organization who has an application and a need? How do you start the process?
Yeah, okay, so any of you who in the room who have worked with Bioteam, we're known for busting heads, okay? We go in, we tell the hard truth as openly and possibly and clearly as we can without completely pissing off the organization in a way that is hard to hear for a lot of organizations. IT doesn't necessarily want to change. They like the way they are. It's a position of power in some cases. Opening up and saying, hey, we're going to be customer focused now. I mean, how many HPC engineers do you know that love to go talk to users? Anyone? Right. So, right, they're rare, but they're necessary in order to really understand the use case, right? And so, I guess my evangelism lately has been about changing the culture so that people want to serve the use case rather than just build cool, shiny things, right?
You know, I would think that from the Bioteam perspective, it's a little bit easier in the sense that that is your job, to come in. If you're embedded in a company and your career or and all those things are at risk, you may have to go a little bit differently. Arden, what's your sense of, you're out there, you're inside a company, maybe you're encountering an issue you think would be better solved, but it's a long sell and the payoff is not so quick. How do how would you suggest people start?
We generally start with pilot programs and work through our vendors, hardware vendors, software vendors. We've been pretty successful at getting other people to do the initial demonstrations for our problems. I like to say we've got a plethora of problems that if anyone wants to go try to solve and then, hopefully get business by providing back that solution to us, that's a good way to get started, at least within our analysis group at Mercury Marine. So GPU utilization is an example. The initial HPC stuff is an example. Things we're doing currently with trying to do material modeling is another example. So relying on our partners in the HPC industry, and that's a way to maybe take some risk off of us. And then also a thing that comes up is there's the ongoing business, right? I've got all the stuff that we already are signed up to do, and then when we want to do more, do different or better, there's not always time to get to that. So that's a way to kind of get over our own way, is collaborate with others that are able to shine a light down that tunnel. And then once we like what we see, we allocate resources, and that's a way for us to plan.
It's a little bit, so you're saying take advantage of, actually, Molly Rector's advice earlier, which is, the science projects, push that on to the HPC vendor community because they're excited about a new market in which to sort of play.
Correct, or academia, but distinctly not us.
Dr. Uddin, did you have anything to add to the, how do you start if you had advice to someone in a company, you want to adopt it, what are the steps?
From my point of view, that as a IT plus as a scientific community, I think we have to always work with the scientific community to promote the HPC and to go around and see what types of support you can give to them, or sometimes hold regular meeting with them and see what they need and can we provide quickly. So from my experience, I can say that this is actually one of the things I'm very proud of, that I try to go to people and talk to them that what they're using, and is there similar technology around that they can use and take get benefited by using that technology. And if it is necessary, we will try to take every step necessary that we can bring that technology and put it in our cluster or our system so that they can use it. Because eventually, the industry is like synergistic between experimentation or product development, and you do that in the virtual environment. So we know by now that it is already 20 years or so HPC is around. High performance computing is a little bit older in a different name, but we have that experience, and some scientists, engineers, they started some of the HPC systems, so they know already. So they also get the budget from their side, and we get it. So our job would be in the IT industry or IT department to work with them, try to get what they need, and try to implement. As Larry has mentioned, that when it comes to money about HPC, there is nobody say no. Whatever we ask, we get it. So just needs collaboration and talking more.
Okay, I want to turn for a second to if you're successful, so you manage to convince the hierarchy inside, whether it's both IT and management, et cetera, to adopt HPC for all these reasons that are going to give you a competitive advantage. What are sort of the consequences from that for IT support, IT budgets, training? How does you make the decision, you're moving forward, how are those things impacted? Is in terms of your training needs, your support needs, your budget? Maybe actually, I'd be really interested to hear what the Gulfstream folks, since you're so separate. I mean, it seems like you would balloon costs a bit there.
Touching back on the last one and leading into this question, and it's your fault that I'm talking a lot because you handed me a mic. So, once you go back to the model, use what you have. Some of us, if I had people like the PayPal guys, I could go from an enterprise world that really speaks HPC. Sorry, I don't have that. If I had a customer base that it grew out of the science world, and they're the ones that are helping spec everything out, and they're really growing it, great, I'll jump on the science side and I'll drive it from there. Yeah. But when you're kind of given a position in a company that's the guy in the middle, great, I'll build it from there. I'll get those guys to drive it, these guys to buy it, because they all know that they're smarter than them, and they're going to say yes. So then once you do a few aircraft, and the 650 is so incredible, and then now you've launched others that you've kept for secrets for so many years, you launch them, and it takes the world by surprise. So now we go prove, hopefully, that we are also the best in class in that market. Once you build some of those things up, like you were saying, it comes down to where it's not as big of an issue. I'm not going to have unlimited, and I try to stay in front of utilization. If they're ever at a 60 or 70% utilization, we all go back to the users and go, okay, I'm headed to get budget. Are you going to use it or not? What are the problems that you couldn't do? How many million cells were you doing, and how many do you want to do? Your X hundred or X thousand cores, okay, can you double it? What were you doing yesterday? All right, I turned over whatever this series is, CFD. What if you could turn that over twice in a day? So at the end of the day, launch another one and it run tonight. So now you get 2 answers during the day. Or what if in the morning you can run a series, hand it to someone else, they're running. By the end of the day, you've gone through a full multidisciplinary optimization, you've gone through a multifunctional thing, and it's gone 3 rounds. So you do one in the morning, one in the afternoon, and launch another one at night. It's not like maybe the labs where somebody launches problems and the scheduler, you have a week or so and you come back and you continue that research. We are affecting the time to market. In a 10-year aircraft cycle, what if we say, no, we're going to do 7-year? What if we say it's not going to be a little bit of a change of the last one? What if I'm going to do a clean sheet and just really surprise the world? What if I'm really going to do all of that aero? That's what we've done in our past, especially like the 650, and it took the market over. So now when you're really trying to do that, you change a 6-month down to a 1 or 2 week, and now you say, do you want to get faster? And they're saying, I can't pre and post all of this. Now it's limited by how many scientists I have and how many engineers I have working it. So you're going, all right, well, now bump it up from the 200 or 300 or 400 million cells, bump it up to 6, or do more points. So now if I can do more points in my CFD, and I know my envelope is here, but now I've proven it through CFD, I can shrink my envelope. I don't have to put all that excessive margin. Without excessive margin, I really get to a good spec that now when I launch the spec that is real. That's straight up competitive advantage.
Well, so the optimization and the time to market are critical for you. That really makes the case. I still want to know, though, in terms of impact on budget. So if you do it in training, so you decide to go this route, I'm assuming there are a bunch of skills that you'd like to bring in-house as well, and there's going to be a cost associated with that. How does that typically play out? And anyone can start with that. Do you want to start with that, Uddin? Or Jamel? Sure.
It's about the budget, about IT training.
Well, training. So if you're changing the way you're doing things, right? You're going from a traditional IT infrastructure. It's never pure, right? There are always bits and pieces, but you're moving into this HPC or advanced scale world. and that requires new training, that requires looking at your budget in a different way for different technologies. What has been the impact? What's your experience with the impact? Do you decide to go the road, do budgets go up? Do your training needs get more difficult? How hard is it to find help? Can you talk about those issues?
Usually, we always evaluate what technologies are around or coming around, or we talk to the vendor and they know us, we call and they call us. So we know that what types of system. One of the things we do at Dana is we are very proactive and futuristic company. We try to bring, when there is a new technology, we try to bring them, do some proof of concept testing. And that gives us not only the overview of the product, we also get some training. We get presentation, we talk to them and know that. And also, Dana is also like, they have the budget, like next year, what we are going to do, how much computational power we are going to increase. We are actually evaluating. That's why there are some of the scheduling system is there. They gave us the analytics of the utilization. We go how much, and we can actually project out that next year what will be our goal to get how many machines, what type of NAS storage we need. So we actually do that kind of research and project out that next year what we need. Suppose we are at this time going through some refresh, we are getting new machines, and we also need to increase some human skilled personnel, and like I got hired by Dana just to adapt that types of demand. So I think corporation, they always try to get some money.
It sounds like in your planning process, you're able to anticipate both the technology changes and the costs associated with that.
Yes.
What about when you go alone as you sort of build your own HPC structure at Gulfstream? What happened with the budget and all of that?
Yeah, I should have answered that question when you asked me, right? Instead of doing the other stuff. Budget. As it went up, as I need more, as we prove, then CapEx budgets, they're on a curve like this. We do get more CapEx. We keep it very, very lean so that when I get into the cloud versus internal discussions, a lot of that comes around money. And Gulfstream believes as long as I have space, keep building. You keep all the data inside, all that secrecy piece. So they give me money, capital, to do that. My refreshes went down from the 3, 4, 5 year now to pretty much 3 year because we've proven once we really speed it up, I can really affect their methods and I can really affect the process. My OpEx for training, they never argue with me. We have the highest per capita in IT, and they do not fight with it. Everyone's jealous of it. That's another reason I'm stealth, and I stay in the back corner and keep our mouth shut, so we're not in any kind of war about it. So highest per capita, probably highest CapEx, and it's all because it's driven from engineering.
But it's the belief that there's a competitive advantage that flows from this. Otherwise,
Absolutely.
Those monies would stop, I'm sure. I've got the high sign for 5 minutes. We had a couple other questions, but I think maybe we should open it up to the audience. I'm sure there are questions here rather than tackle. I mean, one thing is I did have on my list here describe the HP systems your company currently uses and also the particular ROIs. But why don't we can do that. You can do it informally with people if they're interested, and let's take some questions from the audience.
So I have a question can you hear me? Question for the whole panel. With the data deluge, business analytics, et cetera, are you getting any inquiries from the business side for utilizing some of these advanced systems or some of your HPC systems?
I'll start with that. The answer is absolutely. And I think that's the whole tenor of this meeting, in fact, and PayPal exemplifies this, is that there is really intense, so on the research bio side, especially at organizations like Novartis or NIH or these folks, NIH grants $28 billion a year to external research, right? That is an enormous amount of accounting that needs to happen. Not to mention that they need to look at what their return on investment is. right? And they have to justify this to Congress every year, right? And there's 27 institutes that have to do this, right? So it's enormously complex. And so this whole idea of grants informatics is something that's really, really coming up, and it's not something you can do on a workstation or a laptop, right? It's too big. There's too much information coming in. And by the way, where's Mike? Most of it's still on paper. Okay, and so now you need to figure that out too. And so everything from medical imaging to electronic health records to these business administration needs, they're starting to seep into this environment. And so yeah, I do think that there's an incredible need for this all over the place, and that currently, the way some groups handle it, and I won't name any names here, is they build two HPC systems. One of them is for research, and one of them is for the business needs, because they can't figure out how to blend that yet. Other organizations are being a little more proactive and using modern technologies to sort of blend those things across at performance.
More questions? Sophie.
Real quick, you already addressed some of this, but in talking to the internal IT groups when you were launching these endeavors, and I've been both an external person as a consultant and an internal IT guy, CIO and director of IT. Some of the resistance, was it around standards, how these systems would be supported, security, the NIH syndrome, not invented here, skill sets? I'm sure you ran into all of those, but I would just like for you to clarify a little bit more on that. And one last comment before you get to that is, I've been on the other side of the equation where a scientist or an engineering group has come up with an app. They love it, and then they just throw it over to the IT group and say, here, you now need to support this. So if you could address a little bit more in depth on those, I'd appreciate it.
Anyone want to take it? Well, you had the NIH name came up, so I guess that kind of fits in your bailiwick.
Merle can comment. He looks like he's jumping out of his seat. But I'll say that that's complex. Okay, you know, in the world that I live in, mostly life sciences, there are no standards at all anywhere, right? And so creating a monolith that supports an unstandardized environment is nearly impossible. Honestly, the closest way to get to that, if performance isn't your primary gain, is cloud, right? And we deal a whole lot in cloud. And one of the ways that we're trying to get there is in hybrid environments where they're both cloud and local for the hard stuff, cloud for the sort of road easier stuff, and then blending that in a way that makes the person using it not care where it goes, right? Application aware scheduling, meta scheduling, things like that. So I think I think the hard thing here is that depending on what the use case is, standards may be wide or they may be narrow. The only way to support it well, then, is to use modern data center environments, scripted environments, DevOps, Ansible, Puppet, Chef, Pixie, images, whatever. Whatever you need, you want to minimize the support burden for it, right? And then if you're supporting an application, make it available to everybody, right? Because you're doing the support, don't just do a unique application for one person. Put that into a development environment, and then use that later. So there's a lot of things we see that are coming about to reduce the operational support burden in life sciences, and it's not an easy thing and requires enormous expertise and.
Hi, is this on? Great stories, thank you guys very much. It was very interesting. And very interesting to hear how you were able to migrate and get high performance computing systems installed. I'm wondering, now that you've got these systems and you've got people using them and you're producing some really terrific results, are your companies asking you to provide a return on investment analysis each year from the use of these systems? Do they hold you to that? Is it informal? Is it formal? Or is it just that your engineers are happy to be able to use this, and so everyone says, well, it must be a good thing, let's just keep investing?
Let me actually give some thought to that. I'll give an example of, we don't actually give the money that how much they have saved, or example is, suppose if you think about a corporation like Chrysler who makes car. Now, they have a proving ground called Chrysler Proven CPG, we used to say. Now, what they do, they're three-dimensional car crash. You put lots of sensor around, and then You crash the car and those nuts and bolts are flying and they try to get the data. And in the past, they used to crash lots of cars, around 40 cars per week. And to finish one car from beginning to end, it used to take $350,000. Now that number has reduced. Now it is around 0 to 5 per week. So you can think of that how much it is actually returning your value. And also the federal mandate used to take those data. Suppose there is a problem with the Jeep now, that it burns, or if you hit it 60 miles per hour, it just ignites itself. So, and Chrysler is fighting because when technology was put, NTSB was saying that, okay, it is fine, it's no problem. Now, that kind of scenario coming, and we are reducing by 2/3 of utilization. And federal government is also taking simulated data compared to physical data. So these are a return of investment we're getting, and there is no money.
Got two more questions. I'm going to, Merle's over here, and I'll bring it right over. Okay.
Larry, you
Yes,
seem to
sir.
have an insatiable appetite for more elements, bigger models. So at NCSA last week, we just ran a billion element model for CD Adapco's Star CCM Plus on 100,000 cores. What fraction of a billion element 100,000 core model would be relevant scale for your best scientists for everyday work?
He loves putting me on the spot to questions I'm not allowed to answer.
I was just saying, I can jump in quick. I'm pretty sure that I've got analysts that would try to use that every day if it was accessible. We say that the resources are like gas. They'll just expand to use whatever's available.
My guys will tell me right now that they don't think that large, and the problems they're coming to me with aren't that large. It is a much smaller scale that they will not allow me to tell you the exact scale that we are on. There will come a time when I will need resources like that. I don't know that I'm there yet. The resources that we throw at them, we do it fast enough to them that it's bigger than the problem sizes they're bringing. And most of the time it's not because of the arrow, it's because of the multidiscipline. A lot of the multidiscipline that has to work in it, homegrown inside systems, and that's the part that slows it down. So Arrow provides way more answers than they need. Loads generating databases and all of that side takes forever, so the process is slowed down. Once, if I could bring some, if I had Mike as our CTO, and we could do more forward thinking, and we could do more really strategic down inside the sciences, and they were really together. If the MDO was sharper, then I would be needing that.
I think we have,
So Ari, you had mentioned something about it problematic with keeping research separate from production. And the only comment that I'll make on that is that while most of what you guys are doing is science and it's pretty much research, even the modeling for the plane, okay, none of that's hitting the financial statement, okay? So for us, we have to keep it separate. We're not allowed to mix production and research because, you know, we're, as AIG, we're monitored by the Fed Reserve as well as SOX, and so we have to be really careful with that. So I think that's probably conditional based on the, you know, the implementation, I would think, because you got to be a little careful with that, I think.
Yeah, Don, you bring up a really good point, and you know, frankly, not something we see a ton of in my field, but we're getting into some places in the federal government that have, you know, similar or even higher level regulation that they have to adhere by, yet they still need to blend it. And there's ways to do it now. Right? There's technologies out there to do it now, like networking, for instance. Everyone tells you, oh, it's got to be air-gapped. It can't even come even close. The reality is that most virtual circuitry now is essentially as good as air-gapped. And it's being tested at the highest levels in very, very secure environments. And you know, basically, if someone says, no, it's not right, you can tell your security officer, you know what, just scan me, you know, to tell me what you find. You know, and the idea then is to converge all the infrastructure into one thing, but it still serves functionally different purposes.
The stick in the mud is the auditors.
Yeah, well, sure.
They want to separate it, it's going to stay separated.
Well, so what I'm saying is that it can be logically separated.
Right.
but still be supported by the same group or organization and still in the same core of compute
We
infrastructure.
involve our execute nodes for research and production, but the submit nodes and the environments that feed those completely separate.
Yeah, right. Yeah, at some point it'd be great to have demilitarized zones in which things can cross over, and you get some benefit from that, but it's going to be a while off. Right.
Let's thank our panel. I urge you to talk with them afterwards. Great panel, guys.